So you just finished up a unit on functions and we're doing more functions. Well, there's a lot of stuff to do with functions. So one of the most critical things is to be able to just give you a function, y equals like 2x plus 7, and be able to have you make an xy chart for it, and then be able to graph those points. This is right off of the basic 20 and the first 20. Can you take a simple little equation, find me some points, and graph them? Let's do that. If you don't know how to do this, this is one of those things I'm asking you to learn on the first 20. Now, how do you know which points to pick? You can pick anything. So pick easy things. And is it easier to pick x's or y's? It's easier to pick x's. So I'm personally going to pick 0 because it's really easy to put in a 0. It just like cancels off the 2. And when you put in a 0 here, you get 2 times 0 is 0 plus 7 is 7, and that 7 goes there. Notice the y is 7, the x is 0, 0, comma 7. Does that one make sense to you? Good. Now put in -1, because I'm just going to tell you, you almost always need a negative number. Otherwise, part of the graph won't show up. Just put in a negative number. And then the other easiest positive number is probably 1. If you want to put in 2, go ahead. All right, I need you to make sure that you can make these points properly. So 0, comma 7 I did with you. Would you please figure out the other 2 points? -1, comma what, and 1, comma what? And compare them with the kid that I always pair you with who's next to you. So I'm going to put in -1 and just show you how that would work. -1 goes in here, and that makes -2 plus 7, which is 5. -1 goes with 5. Raise your hand if you had 5 for that one. Awesome. And then if you put in +1, that goes right here. 2 times 1 is 2, plus 7 is 9. And so 1 goes there, and 9 goes there, and that's another point, 1, comma 9. Does that make sense to you? Then if you graph those points, you've got the third, we call these representations. The third representation is in the form of a graph. We got an equation here, we got a set of points here, and we got a graph here. So would you please graph this thing? Just make a little xy, x-axis, y-axis. And I know some of you are like going, oh, what's the slope again? And what's the y-intercept? Don't need to do that. You've got 3 points, 0, 7. That happens to be the y-intercept right there. And -1, 5. And +1, 9. And look at that. They're all lining up in a nice straight line. Does that make sense for you? Okay. I kind of missed, but pretty much like that. That is my graph. Okay, now, one of the things you have to do for all the graphs today is tell the domain and the range of them. Write this down. Domain is left, comma right. I'll explain that in a second. Just copy it. Domain is left to right. If you focus on the graph of this function, how far will it go to the left? Won't it go forever to the left? What's the math way to say forever? Infinity. But in this case, it's going left forever, which isn't infinity, it is negative infinity. All right, you learned something. Put a parentheses, say negative, and instead of drawing the sideways 8, which would totally be okay, you know, this thing, you can use INF. The reason I like that is because on the Schoology quiz, there is no infinity symbol. And so you're going to have to type INF on the Schoology quiz anyways. So, and how far does this thing go to the right? Positive infinity, INF. That is called the domain of this function. Those are the x values. Do you agree that the x values run from left to right? See, that's the x-axis. It goes like this. So this function, the black line, it goes forever to the left and forever to the right. All right, how about the range? Put an R, colon. If domain was left to right, what do you think this would be? Up and down, but it's weird. It's down, comma, up. And there's a reason for that. Why is down first? Because when we put them in a little parentheses, the first number in the parentheses before the comma has to be the smaller number. And if I said up to down, it would by accident always be the bigger number first. It has to be smaller number first, so it has to be down, comma, up. So, range is really down to up. What's the furthest down that this thing goes? Negative infinity. Down is negative infinity. Infinity just means like a number you can't stop, but this is going down, so it's negative infinity. And then, how about up? Infinity. Okay. Negative infinity and infinity. All right, so let's talk about a different graph. Y equals x squared. Anybody remember what this thing is going to look like when you graph it? What? It's got a curve to it for sure. What letter would it look like? Kind of like a U shape. Very good. Okay. Now, let's actually see by making an XY chart what the points should be that we should graph to make this U. It's not just like a U that's any way you want to draw it. It's got a very specific curve to it. So, find me 3 points. See why that's a top 20 skill? Sorry, a basic first 20 skill? You'll eventually, by semester 2, I'll have gotten you through the basic 20, which was super easy on the first day. You guys all got really good scores on that. The first 20 is the one where the average score is still a 10 out of 20, which is not amazing. We got to fix that. I think this one's on the first 20. Eventually, second semester, you get to the top 20, and that's a total of 60 questions from algebra that you really had to know. We'll slowly get you through them. All right. Do you realize you can put in any numbers you want? So 0 is a pretty good one. If you put in 0, you get 0. Because 0 to the second is 0. And I did say to always put in a negative. Because see, otherwise, let me just show you what happens if you don't. Wait, 1 squared is not 2. 1 squared is 1. 2 squared is 4. If I only graph positive numbers, you get how this thing doesn't look like a U? I got to get some negative numbers in there. Everybody put in -1, please. So that it's going to go back up on the other side. -1, -1. That makes sense? It does not make sense. I said something wrong and nobody's stopping me. -1 does not give you -1. -1, when you put it in here, does not give you -1. What does it give you? +1. I know some of you were thinking it. You just were like too afraid to tell me. That was wrong. -1, +1, right there. That point is now correct. Okay. Do you get? I start with an equation. I can make points. And then anybody can graph points. If you can't graph points, you should not be in honors. Or I shouldn't say it that way. You better learn it quick because graphing is going to be a big part of this class. So, all right. So there, I got it graphed. What about this one over here? Well, you can't go forever. I mean, in fact, we specifically are going to require that you only graph points as far as the graph goes. So in other words, obviously this keeps going up and, you know, like you could go forever. We're not going to make you do that. Just make as many dots as you can to fit on the graph. Okay. Oh, wait. Domain and range. Every single time. Domain and range. And I would almost bet you that you're going to do this wrong. I know it's a bold statement with a lot of really smart kids in the room. Because there's some little gotcha that only like 2 kids are going to remember. Domain is left to right. Right? How far to the left does this graph go? I know you're like, oh, it's going up. Isn't it also going to the left? Isn't it going to keep on going to the left? Yeah. Negative infinity was correct here. And I think most of you probably had that. And infinity, regular infinity, is correct here. It's not that. Range. One mistake that's I guarantee somebody made is they said up to down. And it's not that. It's down to up. What's the lowest it goes? 0. What's the highest it goes? Infinity. But there's still something wrong. Do you know? All right. Then, this is new information that probably nobody in here has been taught. When you're putting numbers in this format with the parentheses, it's called interval notation. Did you know that when you touch something, it's kind of like a graph where it's like, here's a 5 and I go like this. Whether I fill in that circle or not matters. Do you get that? If I fill this in, that means it can be 5. If I leave it empty, it means it can't be 5. Do you get that difference? Well, there needs to be a bracket here on the 0. 'Cause why? 'Cause it touches 0. But we were going to infinity before, but did you actually touch infinity or just go towards infinity? You went towards infinity. There's a difference there. So, I'm the one who gets to teach you all these little picky things. There are a lot of little picky things in the world. Did you get that you can go right on red if you're driving, but you can't go left on red? Who wants to give me the picky part? Unless it's on a one-way. Very good. Then you have to go left on red. What? If you're going on to a one-way, and again, you aren't drivers yet, most of you, so you maybe wouldn't have a chance to learn that yet. But life is picky. There's a little picky things. And in some states, you can't go right on red. Did you know that? In Minnesota, you can, but in other states, you can't. You can't take a right turn at a red light. It's just illegal. All right. So, be careful. If it can touch, then it's got a solid dot and you put a bracket on it. All right, so here's one more that's kind of like that. Except this time I'm just going to give you the graph. It's going to go from here up to there. That's going to be a filled in dot at 9, 2. And this is going to be an empty spot at -2, -4. Now, let's see who can conquer the domain and range for this function, being careful with how you write it. All right, so if I was new at this, I would have gone, okay, so domain is left to right. How far to the left does this function go? I guess that's like this way. Of those two numbers, Oh, it'd be the x, because that's how far to the left it is. So -2. And does it touch there? No, it does not touch there. Parentheses. Comma, how far to the right does it go? Of these two things, that's the 9, and it does touch there. Bracket. Who conquered that one? About half of you. Process it. If you got it wrong, do you understand why you got it wrong now? Domain is the x's. This is the x, and this is the x. Range is the y's. So it's obviously -4 and 2, but do I put parentheses or brackets? Well, it depends. This one is empty. You can't touch that spot. Parentheses. This one is at a closed spot. It does touch that spot. Brackets. There it is. That's about as tough and weird as domains and ranges get. Okay. Now, the weirdest of all the functions. Everybody write y equals 1 over x. This is the strangest of all the functions. For this one, I still think it's best to make an XY chart and then graph points, but there's only going to be a few nice, easy points. There's going to be a lot of weird decimal points, but I think you'll notice something as we make some points. Can you even put in 0 and put 1 divided by 0? No, that doesn't exist. You've never had a function before and had to graph it, where part of the function didn't exist. I'll show you what to do, but for right now, just don't put in 0, because it won't work. All right, so what would work pretty well? 1. Everybody put in 1. And if you put in 1, x is 1, and then y is 1 over 1, which would be 1. 1 comma 1. Cool, I can graph that. That's easy. Put a dot right there. You're right. 1 comma 1. I'm a little off on exactly where that is. 1 comma 1 should be a little more symmetrical. It'd be like that-ish. Okay. Yes? -1. Ooh, -1 would be another thing to put in. Because when you put in 1 over -1, you get -1. And so another good dot is right there. But those are the only clean points. All the rest of them are weird decimals. But you'll probably catch on to the pattern. So what if I do put in 2? I'm not afraid. I'm going to put in 2. I put in a 2 and I go 1 over 2, which is 1/2. That's not that bad. Over 2 and up 1/2. Over 3 and up 1/3. Over 4 and up 1/4. Over 5 and up 1/5. It's getting really, really close to 0. When's it going to hit 0? Never. Even if you put in 100, yeah, 1 over 100, it still isn't 0. It's 1/100th. It's really, really small. It's not 0. So you've probably never seen this before, but this graph has what's called an asymptote. That's where the function can't exist. There's a dotted line that the function will get really, really close to. And if I do it in the other direction, I put in like more points, they would go like this, and they're also not touching that way. So there's a dotted line that runs right on the y-axis, and that's called a different asymptote. Do you guys know your horizontal from your vertical?
Yes.
Horizontal, is that the green one or the red one? Horizontal is the green one. It's like the horizon, okay? So it's really easy to get them twisted in your head. The green one is on the x-axis, but it's y equals 0. I want you to process that for a second. It's the opposite of what you would think. The green one is horizontal, and the horizontal is the x-axis, so why isn't it x equals 0? Because if you graph x equals 0, it's this red line. The x-axis is where y is 0. Another way to say it is every one of these points that's on here has the y is 0 on it. All the x's are different, but the y is always 0. So that dotted line across there, the horizontal one, is y is 0. I sometimes call it the horizontal asymptote. Horizontal goes with y. So how about the vertical asymptote? The vertical is this one. And it is not the y you're seeing for y-axis, it's x equals 0. The zertical asymptote. You know, start the word vertical with an x, you get zertical. I know, it's stretching, but however you want to remember it, the horizontal is the y equals 0, 1. The vertical is the x equals 0, 1. Okay. What if I had a function, and you will, when we get to the harder unit, that was like this? Do you agree that has a vertical and a horizontal asymptote? All right. Let's say this one goes through 3, and let's say this one goes through 4 down here. What's the horizontal asymptote? Careful. Horizontal asymptote. It's so easy to go, oh, it's like the x-axis, so it's x equals 3. It's y equals 3. Horizontal, horizontal. Okay? And what's the vertical asymptote here? It's obviously 4, but what equals 4? X equals 4. Vertical, zertical, x numbers. Horizontal asymptotes, those are the y's. Horizontal, horizontal. All right, and if your brain is ready for it, here is the 1 over x function, but I have moved it 4 to the right and up 3. Whoa. That probably was too much. That's not on today's assignment, but I'm just kind of telling you ahead of time what horizontal and verticals look like. And in your functions, you'll be able to tell, oh, that's the thing that's been moved to the right or left, and this is the thing that's moved it up or down. And my normal y equals 1 over x graph has been moved 4 to the right and up 3. Okay. Let's actually start the Schoology quiz. Everybody open up the Schoology quiz. Once we do a few of them together, I think you'll get the hang of it. So find the Schoology quiz that is posted for today. Question number 1 says, it gives you the graph of the x squared, it's the parabola one, and it asks y equals what? Well, I just said it. You guys have a short-term memory? Y equals what? X squared. Good. Now, it's already got the y equals in there. You don't type y equals y equals. They want to know y equals what? X squared. How do you type squared on the iPad? Caret 2. That's your equation for that graph. Okay. And what else does it want? Is it domain or range? I can't remember. Range. Okay. It wants the range. As I look at this thing, domain we usually did first. That was left to right. How about range? What is that again? Down to up. What's the lowest it goes? Does it touch 0?
Yes.
Bracket 0 to INF. Remember, there's no infinity symbol. Parentheses. There's your equation, and there's your range. Remember, it touches 0. That's why it has a bracket on 0. Yes?
Should we put in a capital F or lowercase?
Good question. That is, whenever you type in answers into Schoology, I'll keep it really simple for you. Always use lowercase every single time. And whenever you type it into Schoology, never put in spaces. Never ever. Okay. Number 2. Some volunteer, just read me number 2.
Complete the table for values over y equals square root of x. And it's
Square root of x?
Yeah. and
Thank you.
it's domain.
And then it's got an x and a y table. And let me copy it quick. 0, 0, 1, 1, something 2, and 9 something. Okay, good. Thank you very much. So, this is saying that y is 2. And I know it feels like I'm asking you to do the square root of 2. I'm not. If the y is 2, then it must have been the square root of what? Square root of x. Yeah, but what's the x value? That would make it equal to. If x was 4. If x would before the answer would be 2. So this is a 4. Do you get that? Because if you put a 4 here, the square root of 4 will be 2. There's always a few kids that got taught this wrong in the first place that think there's 2 square roots. There isn't. The square root of 4 is just 2. It is true when a problem is like this, there's 2 answers to a question, but it's not because there's 2 square roots. This one would be 4 and negative 4, but it's not because there's 2 square roots of 16. There's only 1 square root of 16. It's 4, period. That's it. The reason that you square root this is you get the absolute value of x. That a lot of people don't know that. And then there's 2 answers to that. There's only 1 square root of 16. That's it. Okay, so for 9, I think it goes the other way, right? And I do the square root of 9, and so I'd get 3, right? There you go. All right, I totally get that this is going to get, like there's going to be difficult moments on this. You're in honors. This is a new chapter. Did really well last time. Just understand that it'll take you a few days before you feel totally comfortable with these. I don't give you a new material, test the next day, right? You get some time to absorb this. Question?
I don't know if you want to cover this, but for that question too, there's also a domain.
Oh, okay. So my opinion is look at what the graph looks like as you decide a domain. So would you agree that the square root graph, in case like you weren't remembering them from the past, the square root graph looks like this: 0, 0, 1, 1, 4, 2. You get how it's going? If you look at the graph, it's so much easier to decide the domain than just looking at the points. If you get all 3 things, the equation, some points, and the graph is the best. Because now I look at that and I can go, oh, the domain is from left to right, and then how far to the left does it go? And the furthest left it goes is 0, and then how far does it go to the right? Infinity, and so you go 0 to infinity. And don't forget the little bracket on the 0. Can you graph points? I hope so. You'll have to be able to graph. It's for sure a thing. Now, I know I kind of expected you to know that, and that's one of these things that kind of sucks about like going to Algebra 2 is I expect you to know Algebra 1, and this is one of the graphs that they taught you, and it's probably been a while. I'll remind you of what all of them look like, and in case you are the type who's like, I want to know all the stuff I'm missing. Well, x squared, that looks like this. Square root of x, that looks like this. Absolute value of x, does anybody remember what that one is? V, very good. 1 over x, that's the weird one I just taught you that as the asymptotes. X to the third. Again, you had this, but it's been a while. Now you might be like, well, how am I supposed to know that? Well, you can make an XY chart, find a bunch of points, stick in 0, and you get 0, and so it goes through 0, 0, and stick in 1, and you get 1, and so it must go through 1, 1, and then stick in 2, 2 to the third is 8. You can like build the graph, but it's a lot faster if you just kind of know how they look. And probably the one that throws people off maybe the most is just y equals x. Do you know what that looks like? Just a straight line that goes through the origin. Y-intercept is 0 and has a slope of 1. Just a straight line. That's y equals x. Has such famous points like 1, 1, 2, 2, 0, 0. Does that make sense? All right. So if you feel stressed about the fact that you don't know these 6 graphs, well then just make some flashcards for it. Memorize them. You really ought to know them. They're going to come up. They're going to be on your next test. Sometimes in honors, on day 1, we teach you so many things that it can be stressful. I've noticed a big difference between honors and regular on that. Kids in regular, their first lesson is like 3 things on day 1. And in honors, it's like 9 things. So just understand that that's normal, and after 2 or 3 days of practicing it, you become pretty fluent and good at it. So, all right, that's all I got for you for today. Finish up that Schoology quiz.